Now let us discuss 53. For the cell reaction, they given that E naught value equal to 0.24 electron volt at temperature 298 Kelvin. You have to calculate the its standard Gibbs energy of the cell reaction. Firstly, we write the given data. They given that E naught cell equal to 0.24 volt, its temperature equal to 298 Kelvin, and it's a Faraday constant equal to 96,500 coulomb mole inverse. You have to calculate del R G naught value. Know that the formula del R G naught value equal to minus N into F into E naught cell. In cell reaction, there exhibits of reduction and oxidation of cells. Here, 2 Fe2 positive plus addition of 2 electron, it will give rise to 2 Fe. This is a reduction of cell. Why? Because addition of 2 electrons. This is called reduction of cell. The next one is 2I minus, it will give rise to I2 plus 2 electron. Here I minus losses its 2 electron. That's why this reaction is oxidation of cell. Here we observe that 2 electrons are present on both sides. That's why here N value equal to 2. That means the number of electrons equal to 2. Now substitute the all values in the given formula. You will get del R G naught equal to minus N F E naught cell. Here N equal to 2 into F value 96,500, 0.24. By calculation, you will get minus 46,320 joule mole inverse. But the given options are in kilojoules. Now divide this value with 1000, then it converted to kilojoules. Minus 46320 by 1000. This gives rise to minus 46.32 kilojoule mole inverse. So conclude that del R G naught value is minus of 46.32 kilojoule mole inverse. So option 1 is our correct answer.